Welcome back. We continue with our unit on statistics. This is Unit 8, Lesson 2. For some of you, this might be a review. I'm hoping for most of you it is a review, and for some of you it might be new. The objective is students will be able to find the mean, median, mode, and range of a set of data. There are multiple parts to this lesson, so please bear with me. Vocabulary section. Some things you'll need to know. The measure of center. Well, this is occasionally called an average or just the center of the data. Some common measures of central tendency are the mean, the median, and the mode. What is the mean? Well, it's the sum of all data divided by the number of data points in the data set. And we'll actually do that. Median, the central value in a set of data. Your data must be in order from least to greatest. Mode, the value or values that repeats most often. Your data must be in order from least to greatest. And the range, the difference between the greatest and the lowest values in an ordered set of data. So now that you have those vocabulary terms in your mind, let's go right to the think about it. Number one, a group of 6 students made the table below about the number of people in their households. They wanted to figure out the typical average number of people in a household using the data. So we can see from this table that Ossie's got 2 people in the house, Leon has 3, Gary has 3, Ruth has 4, Paul has 6, and Arlene has 6. Now, one student, Robert, said that the median is 3.5, so the typical number of people in a house is between 3 and 4. Now, A, just to be sure, what does 3.5 represent in the context of this problem? 3.5 represents that there are between 3 and 4 people in each house. Simple. B, how did Robert get 3.5 as the median? Good question. Let's see. He lined up the numbers from least to greatest here, 2, 3, 3, 4, 6, 6, and found the number in the middle. Since there are 2 values in the middle, 3 and 4, he found the midpoint between them, which is 3.5. In other words, he lined up all his numbers from least to greatest, 2, 3, 3, 4, 6, 6. He found numbers that were in the middle, and he found 3 and 4, and he looked for the midpoint. The midpoint is a value that is halfway between 2 values. So halfway between 3 and 4 is 3.5. What is the median of a data set? Well, the median of a data set is the value that represents the midpoint between all data points. It tells you about the center of a data set by splitting the data in half. Once you have your list of numbers in order from least to greatest, finding the midpoint is relatively simple to do. Give you a moment to look at that. And let's go to the next page. Now, another student, Michelle, had a different idea on how to figure out what was typical. She first represented the number of people in each household using cubes. So here's Arlene, Paul, Ruth, 4 cubes, Gary, 3, Leon, 3, Ozzy, 2. She then redistributed the cubes so that each household had the same number of cubes in its stack of cubes. So she made sure that she took all the cubes and reshuffled them around so that there were the same number of cubes here for Ozzy, Leon, Gary, Ruth, Paul, and Arlene. What she did is something called the fair share method. So A, using Michelle's fair share method, how many cubes are in each of the 6 stacks after she redistributes the cubes? In other words, how many cubes will now be in Ossie's stack? Leon's stack, Gary's, Ruth's, Paul's, Arlene's. After all the cubes are shuffled around so that everybody has the same number of cubes in each stack. In this case, to fair share means that each stack, which represents each person, would have an equal number of cubes in it. When we count the number of cubes in each original stack, we get a total of 24 cubes. So if we counted 6, 6, 4, 3, 3, and 2, you get 24. If we gave each new stack, there would be 6 stacks, one for each person, a cube out of the 24 total cubes, then each new stack would finally have 4 cubes in it. So after she redistributes all these cubes so that everybody has an equal stack, there would be 4 cubes for each stack. B, according to the data, do you think the number of cubes in each of the new stacks is representative of the typical number of people in a household? And why? Well, do you or not? Let's see. I do think that 4 is representative because it is between the least 2 and the most 6 number of people in a household, and it's towards the middle of the data. So if you look at our data, two, three, three, 4, 6, 6. 4 is roughly in the middle, but you have to make sure your numbers are ordered from least to greatest to be able to see that middle value. All right, let's go back. Here's our key point. There's 2 actually. The mean defines the center of a data set by taking into account all data points. And the median defines the center of the data set also by splitting the data in half. So we're going to keep these 2 key points in mind as we work on the new material. So let's look at this. Exercise 1. Michelle asked her classmates for the number of hours that they usually sleep when there's no school the next day, because we all know when there's no school the next day, everybody sleeps in a little bit longer or a lot. So their responses are recorded below. So one person slept in 7 hours. This is a dot plot, by the way. It's made up of dots. That's why we call it a dot plot. So one student said they slept in for 7 hours. 4 students, because there's 4 dots, said they slept in for 8 hours. So that's 1 7, 4 8s. One student said they slept in for 9 hours. So that's 1 9. 2 students, 2 dots, said they slept in for 10 hours. That's 2 10s. And 2 students, 2 dots, said they slept in for 11 hours. So that's 2 11s. 1 7, 4 8s, 1 9, 2 10s, 2 11s. There are no 12 hours people, no 6-hour people, 5, 4, 3, 2, 1. None of that. Just these. Now, A, use the dot plot above to determine the average or mean number of hours of sleep that her classmates get on a weekend night. And what does this value represent? So here we begin. Here's the process. Add up all data values, then divide your sum by how many data values you have. Let's do that. When we look at this dot plot, we see the following values and their frequency. 7 once, 8 4 times, 9 once, 10 twice, and 11 twice. That's 10 values in all. 2, 4, 5, 9, 10. 10 values in all. As an ordered set of data we get, putting them in order, 7, 8, 8, 8, 8, 9, 10, 10, 11, 11. Let me check. 10 values in all. 2, 4, 6, 8, 10. Making sure I still got my 10 and my 10 that I'm working with. So I add them up. Add up all my values. I get 90. You can double check that. We get 90. We got 10 values. So we take our sum and we divide by 10. 90 divided by 10 is 9. And the question is, what does this value represent? Well, 9 is the mean or average number of hours of sleep when there is no school the next day. According to this problem, that's what the average means. So I'll give you a moment to look at this so that you can see what we did. The process is add up all the data values and then divide your sum by how many data values you have. This should be familiar to some of you. I'm hoping most of you. All right, let's move on. B, use the dot plot above. Remember this dot plot to determine the median number of hours of sleep that our classmates get on a weekend night. And what does that value represent? Well, let's take a look. Here's the process. Put all of your data values in order from least to greatest. Now, two things can happen. One of two things can happen. One, if you have an odd number set of values, then your median is right in the middle. Or if you have an even number set of values, then the median is the mean of your two central values. What does that mean? Well, let's take a look. As an ordered set of data, we get, again, 7, 8, 8, 8, 8, 9, 10, 10, 11, 11. 10 values in all. That's an even number set of values. 10 values is even. Then the median is the mean of the two central values. So the two numbers that are in the middle are 8 and 9. They're right there in the middle. You can only see them once your set is in order from least to greatest. Now look at where the midpoint is pointing. It's pointing between 8 and 9. The question that I have for you is, what's the midpoint? Let's check it out. Since we have an even number set of values, then the median is the mean of our two central values. So the mean, we take 8 and 9, those are the two values in the middle, add them up, divide by 2. 8 plus 9, 17. Divide 17 by 2, you get 8.5, which makes sense. What's halfway between 8 and 9? 8.5. This mean is a single value that summarizes the data set and represents the typical number of hours the students sleep when there is no school the next day. That's what the mean signifies. Actually, we're looking for the median. Correction. It's always good to check your work. Moving on. C. Michelle asked two more people how many hours of sleep they get on a weekend night, and they both said 6 hours. What is the mean of the data set after adding two more data values to the data set? So originally we had 10 data values. Now we're going to have adding two more. So that gives us, you guessed it, 12 data values. Let's add the two sixes to our original set of data. But instead of rewriting out the whole list of numbers, we don't have to do that because it's a short list. When the original total was 90. Adding two sixes to this gives us 102. Adding two sixes also means we now have 12 items in our data set instead of 10. Mean, 90 our original sum, plus the two more sixes, divide by 12 now. 90 plus 12, 102. Divide by 12, we get 8.5. E, does it make sense that our mean decreased after adding the two sixes? Remember, our original mean was 9. After adding the two sixes, we now have 8.5. We added two sixes and the mean decreased. Why would that happen? Let's see. The original data set, 7, 8, 8, 8, 8, 9, 10, 10, 11, 11. The original mean, 9. The new data set, we added the two sixes. The new mean, 8.5. It makes sense that the mean decreased since we added data points that were below the rest of the data. In other words, in our original set, we got these numbers. If we're going to add more numbers that are lower than the smallest value in the original list, chances are your mean is going to decrease. The opposite tends to be true as well. If instead of adding two sixes, we added two 15s, and those are greater than the original largest value, then our mean would be higher, assuming nothing else changed. That's an important concept. All right, almost done. I know this is long. That should be G. Find the mode of the dot plot. Remember, here are our values in the dot plot. The mode is the value which repeats more often than the rest. Your data must be in order from least to greatest. In this case, it's 8. How do I know? 8 shows up more than every other value in the list. That is our mode. Find the range of the dot plot. Last part. Remember, the range is the difference between the highest and the lowest value. The range is the difference between the greatest and the lowest values in an ordered set of data. In this case, it's 4 because 11, max value, minus 7, minimum value, gives us 4. So I've talked about a lot. Feel free to rewatch the video if you need to, but now it's time to practice.